So the next topic here we're going to be going through is our programming editors. So that there are 3 primary programming editors for Rockwell. I'm sorry, there are 4. I'm going to highlight 3 of them today. So our first one is ladder logic. So most PLCs come from this style. So ladder logic is the traditional, most commonly used, especially in the Rockwell world. Some other platforms are very, very hybrid between ladder logics and potentially a structured text or a higher function style like that. The benefits for ladder logic are that you get to see that power flow or you get to see what is actually executing. And it's much easier to comprehend because you have signaling cues that tell you something is happening. Ladder logic is referred to as ladder logic because you have a power band on the left-hand side and on the right-hand side. And then if you see green go across, that means that logic is executing. You have continuous flow. Ladder logic stem from electrical diagrams, so that's why you have just contacts and coils, but it has progressed since then. The next editor is the function block editor. So the function block editor, with the newer ones, they have functions that are smaller and better. So there's no backing tag. They're physically a smaller footprint. So if you've ever worked with function block diagrams, you have a sheet in which you can add all of your logic, but you have a finite amount of room. It's not like a ladder where you can continuously add rungs to the bottom. You need to fill that sheet, and once you run out of room, you either need to make a bigger sheet or jump to another sheet. So it makes it a little bit more complicated. So on the right-hand side was the traditional way of doing it. This left-hand side is how they look. So you can see it's just smaller, and there is no need for this extra back tag, which is really just a waste of memory. The other thing that Rockwell has done recently, thank God, in version 32, is they added wire jumps to function block editors. So previously, in the event you had a wire that crossed these other 3 horizontals, you could not trace it. It was very difficult. It would actually just have a 4-way intersection, and then you didn't know where it was. So you'd have to click on it and drag the wire to understand where it's actually going and what it's connected to. Rockwell has finally added these jumps, the wire jumps, the same as you would see on an actual electrical schematic. The next editor, like I said, that is somewhat more common in other platforms, and it does look similar to either C or Java scripting or Python dependent, would be the structured text editor. So the structured text editor prior to version 31 was really, really atrocious. I don't recommend most people use it. The reason being is the lines were not numbered. You could not see the data points, so you would not see live values executing, and it just made it very difficult to understand and comprehend what the code was doing. Even if you did understand the syntax, it still made it very difficult to understand what was actually happening. So they made a bunch of changes which made it easier. The other thing that they have done is they added what they call code snippets. So they have an if-then, a case, a do-for, a do-while, and a repeat until. So they pre-built these codes into the structured text editor now. So in the event that you type in the word if, it will pop up and one of the options will be code snippet. And if you hit enter, it will enter the proper syntax and show you how to create an if-then statement in the Allen-Bradley structured text editor. So these little code snippets have made it also easier for people to understand. Plus, it is now standardizing how they do it because Rockwell is embedded in there. So you could execute an if-then statement on your own previously, but the format could not or may not match the next person who would do it. So it's the same kind of concept that people don't like for ladder logic, that there are always, 10 ways to skin a cat, so to speak. So you have to know how that individual person does it, as opposed to when they create snippets or add-on instructions or something like that, that the code is always identical, and it makes things easier and more easy to track. And the fourth one, which we're not going to cover very much today, it is another programming editor would be the sequential function chart. So this allows you to create almost a flow diagram of how you want a sequencer to work. Many people still use either a Boolean sequencer or even a double integer sequencer where you will just write a step number, so step 0, 1, 2 inside ladder logic. That is still the most common way of doing it, but Rockwell has come out with this sequential function chart to give you that graphical type setup. And then each step can then have an action assigned to the step. Each transition could also have it. So the transition would be a condition to move to the next step. So it will hold in the previous step until this transition becomes true and then move down. And then while in the step, you can be executing. If you're not used to sequential function chart, it's a little bit more difficult to comprehend because your actions will not be executed inside the same area. So you'll have a sequence, but then you potentially will have either a function block or ladder logic or structured text doing the other actions, right? See, because you cannot fit everything inside those actions. But if it's as simple as creating the steps for you, it will make your ladder logic simpler and easier to follow. All right, the next thing we're going to quickly kind of go over is trends. So inside the controller, you can trend any tag. It allows you to sample at 1 millisecond. So it attempts to sample as quickly as possible. So as fast as, so this is really designed for I/O. So in the event you want to see if an I/O signal is dropping or something is changing that you can't see quickly in the editor because the editor doesn't update fast enough for you, you can do a trend. I have used this specifically for like safety conditions. We were running and in the middle of operation, our machine would stop, throw a safety fault signal. By the time you look at the code, everything looks fine. You hit the reset, starts running again. It would do this every couple of hours. We just couldn't figure out what it was. What I ended up doing was putting a trend on my safety signals, both in and out. And I found that my safety input signal had dropped with less than 2 milliseconds. So it would drop for about a millisecond and a half, and then come right back. And that was good enough that it would stop all my servos because the safety signal dropped. So trending has the ability to add multiple tags. You can configure the trend, and it also will store historical information for a finite amount. It's not infinite, but it can store what is available on the controller inside this trend. As soon as you close the trend, all that information immediately gets erased because it is not stored in permanent memory. It is stored in RAM. But if you leave the trend running and then someone tells you, hey, this happened, you can come back and scroll back and watch and see, and you'll be able to see the event occur. Otherwise, it will only pull in live data. Once you scroll all the way to the back though, or once you stop collecting live data and start scrolling back into historical data, it will no longer keep updating with new information. So you got to keep in mind that you will lose any new information that would be coming in when you are looking at historical data. Graphic itself is configurable. When you double click on it, this is what you get. You get this little editor. You can add multiple tags. Again, you can change the color of the tag, what you want, the width of the line, if you want one to be thin versus thick, the type, so you can have analog or Boolean. If you are doing, like I was looking at discrete I/O, you can trigger the trend to start in the event that something happens, this is a newer property, which is very, very nice. You can have a start and stop trigger. So trend only while these are on the start condition and stop at some other condition. So like a sequencer, you can trend, motor or VFD or something like that at the start of a step, and then the next step would be a stop trigger. And then there's many other options that you can configure inside the display configuration.